How are you all? I hope you all are doing wonderful. So as you all know that I started with the JEE main previous year question sessions. In each of the session, I am discussing top 10 or 15 important JEE main previous year questions for each and every topic of mathematics. So as you all know that I have covered the coordinate geometry portion and I started with the algebra. And in algebra, I started with quadratic equation and complex number. And as the hour of the need, so we start with the sequence and series. So here's my take on the sequence and series, and this is session number 8 on the topic of sequence and series. So if you have been following me for a long time, then you must know how we basically proceed with these sessions. And if you're someone who is new, who is starting to watch these particular sessions from this particular video, then I will recommend you to go to the playlist which you will find in the description box of today's video and start watching the first lectures. Okay, so with this, let's get started. And today's goal will be basically to solve the chapter sequence and series, and we basically take up 10 important JEE previous year questions, also along with one bonus problem. Okay, so I will be taking one bonus problem. Okay, I will be discussing one bonus problem and I will be leaving that answer to all of you. Okay, so let's get started with the very first question. So if you have been knowing that how to basically proceed with the sessions, you basically need to pause the video at this particular moment and start to solve the question on yourself. Okay, now once you get to the answer, tally the answer as well as the solution with mine. Okay, so that's how we basically proceed with these question sessions. Okay, and definitely comment me in the comment section how many scores you basically get in the in this particular session, with marking scheme as +4 for the correct one and -1 for the incorrect one. I hope you will follow that and I will be eagerly waiting for your comments. Let's get started on the very first problem. So the first problem says that let A1 and A2 be the arithmetic means and G1, G2 and G3 be the three geometric means of two distinct positive numbers. Okay, and then we have to basically look for the value of this particular expression. Okay, now let us assume let the two positive numbers, okay, let the two positive numbers be A and B. Okay, so let us assume that the two positive numbers be A and B, where A and B are both positive. Okay, where A and B are both positive real numbers. Okay, now it is saying that A1 and A2 are the arithmetic means. Now you must know that whenever we talk about arithmetic mean or geometric mean, you don't have to remember different formulas. Rather, you can assume that you also know that if A1 and A2 are the arithmetic mean of A and B, then you can assume that these numbers A, capital A1 and capital A2, comma B are in arithmetic progression. So if you have studied the chapter of sequence series, then you must know these particular important things, that instead of remembering the properties or learning the different formulas for arithmetic means, we basically try to solve the problem by making it a problem of an AP. Then from here, what I can say that these particular numbers are in AP, that means the common difference is basically of D. So let us assume that there is a common difference D between these particular numbers. So if you take the difference of these particular numbers, consecutive numbers, you get the difference as D. From there, I can definitely write B as the first term plus n minus 1. So if you look at the B is basically the fourth term of the AP. Okay, that is the n minus 1, that means the 3D. Okay, so that is equal to 3D. So this is B, and if I say what is the value of, now if I say what is the value of B minus A, you will say me that the value is equal to 3D. Okay, so let us assume this is the first equation, or better to say that if I assume that value of D as the first equation, so let me divide by 3 and write the value of, okay, write the value of D as B minus A divided by 3 is equal to D. Now what I can look for is that if I write A1, now A1 is basically equal to A plus D, and similarly A2 is equal to A plus 2D. Okay, you can definitely observe. Now if you put the values of D back into this particular equation, you will get the value of A1 as, so if you put back, you will get the value of A1 as, okay, you will get the value of A1 as 2A plus B divided by 3, and similarly the value of A2 is equal to A plus, okay, and you will get the value of A2 as equal to A plus 2B by 3. Okay, now what I want to look and observe is that if you sum up A1 and A2, you will get the value as equal to, A plus B. Now this is true for any it is true for any arithmetic progression. That is what I am trying to say. If you, for example, there is a arithmetic progression, something of this, let me take a different color. So if you have an arithmetic progression like A, B, C, D, E and F. So if you look at the extreme numbers, okay, that is the first term and the last term, if you sum them, and also if you sum the the second term and the second last term, you will also get the same sum, as well as if you take the sum of the third term and the third last term, you will also get the same term. That means if you take the sum of the equidistance term, you basically get to the constant result. Okay, so that's a very important property of an arithmetic progression. I hope if you have studied the chapter of arithmetic sequence and series, then you must have studied all these particular properties in detail. Okay, so you can directly write this value as a1 plus capital A2 is equal to small a plus small b. Okay, so you can write this particular value. Okay, now again it is also saying that in between a and b, g1, capital G1, capital G2 and capital G3 are in geometric progression, because G1, G2 and G3 are geometric means of the two distinct positive numbers. That means these are in GP. Okay, now if they are in GP, they basically need a common ratio. So let us assume the common ratio. Okay, so let us assume the common ratio to be R. Okay, so if you assume the common ratio to be R, what I can write B as? So B I can write as first term into R raised to the power n minus 1. So if you look at B, it is basically the fifth term. Yes, so n value is equal to 5. That means R to the power 4, and from here you will get the value of R as equal to B by A whole raised to the power 1 by 4 is the value of the R. R is a positive value, and that value is equal to B by A whole raised to the power 1 by 4. So I hope you will get to the value of this common ratio as this particular following. Now what I will be going on and doing is basically I will find out the value of G1 as, so it is equal to A into R. So if you compute this result, this is basically A into B by A whole raised to the power 1 by 4, whole raised to the power 1 by 4. And if you compute this result will be basically equal to A to the power 3 B whole raised to the power 1 by 4. And similarly the results goes on in the following as G2 is equal to AR square, and similarly G3 is equal to AR cube. Okay, by simply using the the properties of geometric progression. So from here, if you solve this and compute both the results, so the second result will be equal to A square B square whole raised to the power 1 by 4, and similarly the third result is equal to A B to the power 3, okay, whole raised to the power 1 by 4. So that's the results you basically obtained as G1, G2 and G3. Now it is asking the problem to basically calculate the expression. Okay, this particular expression you need to calculate. Okay, so if we do this expression, that is the expression that is given, now we have to find for the expression that is G1 to the power 4 plus G2 to the power 4 plus, okay, so we have to look for G1 to the power 4 plus G2 to the power 4 plus G3 to the power 4 plus G1 G3 whole raised to the power whole square. Okay, whole square. So this is whole square. Okay, G1 G3 whole square, that means G1 square into G3 square. Okay, so that is the value that is basically asked to, like, expression that is used to compute. So let us do the following, and if you do the following, you will find that G1 whole to the power 4 is equal to A cube B plus G2 whole to the power 4 is equal to A square B square. Similarly, G3 whole to the power 4 is equal to AB cube. Okay, and the last term G1 into G3. So if you compute G1 into G3, so let me do that. So if you compute G1 into G3, this value will be equal to A to the power 4 and B to the power 4 and whole to the power 1 by 4, and that is equal to A into B. Also, again, if you have studied the chapter of this particular chapter, then you must know that the product of the equidistance terms for a GP is also the same. So if you compute the product of A and B, and this will be equal to the product of G1 and G3, and this will also be equal to the product of G2 with itself. That means G2 whole square is also equal to A into B. Okay, so you can try out this and understand these properties. These are very, very important properties, similar properties as of the AP. Okay, in AP we just need to sum for the equidistance terms, and in GP we need to product the equidistance terms. So that, I hope you will remember these important properties. So from there I can write this G1 G3 as A into B, and whole square will be A square B square, A square B square. And if you see, so from here, if you just simplify these results, you can definitely factorize out, like from the first terms, you can basically take out A and B as common. So you will get this as A square plus AB plus, so from here also you will get AB. So this will be 2 times of AB, and this will become equal to B square. So if you compute this result, this is equal to A into B into A plus B whole square. Okay, and this is A plus B whole square. Now if you remember the results, so this AB is basically equal to G1 into G3, And similarly, a plus b is also equal to capital A1 plus capital A2. So that will be into multiplied with capital A1 plus capital A2 whole square. So I hope you will get the expression that is basically asking the problem in the terms of G1 and G2. So this result is equal to option number A. So if you compute this result, you will get this as option number A. So I hope if you have solved this particular problem on yourself, you must have got the answer as option A. Alright, so this is a fairly simple problem, but again a tricky problem. There might be a mistakes, okay, chances of mistakes in this particular problem, because whenever you basically try to solve this particular, you might encounter error also. Okay, so definitely look out that you don't make some error, okay, or a silly mistakes. Rather, everything is wonderfully fine. Okay, so let us move to the, and with this let us move to the next problem. Next problem is again a problem of an GP. Okay, so if you look at this GP problem, so it is saying that let A1, A2, A3 be are all in GP of increasing positive number. So that means basically a GP whose common ratio is greater than 1. So it is said that the sum of its sixth and the eighth term be 2 and the product of its third and the fifth term be equal to 1 by 9. Now why do I take up these questions? Because many times you will see these types of problems are actually getting repeated many number of times. A simple problem of an AP or a simple problem of a GP. Okay, so you can see that, so it is said that A1, A2, A3 are the numbers are in GP. Okay, so these are the numbers which are in GP or a positive increasing GP. Okay, increasing positive numbers. Okay, that means R is greater than 1. So it is said then the let us sum of the sixth term and the eighth term be equal to 2 and the product of the third and the fifth term be equal to 1 by 9. So if you look at the sixth term, okay, so before starting, you know that for a GP, the rth term is given by the first term r dash to the power, or let me write this nth term, okay, that is given by the first term multiplied with the common ratio whole dash to the power n minus 1. So that is the nth term of any GP. Okay, so that is the nth term of any GP of a GP. Okay, now for the sixth term of this particular GP, this will be equal to A1. Now R is the common ratio r dash to the power 5, and similarly the eighth term. Okay, so if you look at the eighth term, so this will be equal to A1 r raised to the power 7. Okay, now if you sum up the terms, the sixth term and the eighth term, you will get the sum as, so r1 raised to the power 5 plus A1 into r raised to the power 7 is equal to 2. Okay, so from here you will get the sum something like this. And now if you if you compute this result by taking out a1 and r to the power 5 common, you will get the result as, so if you take a1 and r to the power 5 as common, so you will get the result as 1 plus r square is equal to 2. Okay, that will, you will get the value of 1 plus r square is equal to 2. And again let me write this as equation number 1. Again it is said that, okay, again it is mentioned, okay, it is said that the product of the third term and the fifth term, so if you look at the third term, so the third term is equal to a1 r square, and what is the fifth term? So the fifth term is equal to a1 r to the power 4, and if you compute the product of these terms, you will get it as a1 whole square into r to the power 6, and this result is equal to 1 by 9. So you can also simplify this result and get as a1 r cube is equal to 1 by 3. Okay, now why did I write is 1 by 3? Because a1 is also positive and r is also greater than 1. But that means I can take the square root of both the sides and write as 1 by 3. Okay, and from here you will get the result as 1 by 3. Okay, so this is a result you remember. And now if you have the value of a1 r to the power 3 is equal to 1 by 3, what I can do from here is basically obtain the value of, okay, is basically to obtain the value of a1. Okay, so from here I can definitely obtain the value of a1. So from here what I can write as a1 is basically 1 by 3 times of r cube. Okay, 1 by 3 times 1 divided by 3 r cube. Okay, 3 r cube. So that's what I can write a1 as. And now the sum of basically the number was actually obtained. So if you compute the sum again, so you will find this as r square by 3 plus, so from this particular equation I am putting the value of a1, so I will get it as r square by 3, and similarly this value will be equal to r to the power 4 by 3, okay, is equal to 2. So from here you will also get the results as similar to r to the power 4 plus r square is equal to 6. Okay, so you will get the result as r to the power 4 plus r square is equal to 6. Now this can be factorized as, so if you can look at this particular term, if you take, so r to the power 4 plus r square minus 6 is equal to 0, so you can definitely factorize these results. Okay, now you can definitely factorize this. Okay, so if you take this will be easy to factorize, so you can take the factor as 3 and 2, so this will be r square plus 2 into r square plus 3 into r square minus 2. Okay, so the factors will be something like this. Okay, the factors will be something like this: r square minus 2 into r square plus 3 is equal to 0. So from here, what you will get, that you know that r is a basically a real number and also positive greater than 1. So r square plus 3 is obviously a positive number. So this cannot never be equal to 0. So the only value that can be equal to 0 is r square equal to 2. So that is r square value will be equal to 2. And if we equate the r square value is equal to 2, we'll get the value of r as root 2, because r is would be greater than 1 and it is also positive. Okay. Now if we put the back this r value in the equation, okay, so if you put back the value of r into the equation, into which equation I'm talking about is basically this particular equation, okay, the value of a. So if you substitute r value, so you can get it as, so okay, so if you substitute this value of r, so a1 into r is equal to 1 by 6. So you can definitely compute this result. Okay, a1 into r is equal to 1 by 6, and also you will get the value of a1 as equal to 1 by 3 into r to the power cube. So that will be equal to 1 by 6 root 2. Okay, so that will be basically equal to, so a1 value will be equal to 1 by 6 root 2, 1 by 6 root 2. Okay, so a1 value will be equal to 1 by 6 root 2. And if you have the a1 value, the first term of the geometric progression, as 1 by 6 root 2, then you can definitely you need to actually find for the expression, that is 6 into a2 plus a4 or multiplied with a4 plus a6. So you have to look for the expression, that is 6 into a2 plus a4 multiplied with a4 plus a6. Okay, now if you solve this with the expression, this will be basically 6 into a1r plus a1 r cube multiplied with a1 r cube plus a1 r to the power 5. Okay, so now you can definitely put back, because you have got to the value of r as well as you got to the value of a1. So if you put the value back into these equations, okay, and if you solve, this will be 6 into, so a into r is basically 1 by 6 root 2 plus, and this is the third term, that is 1 by 3 root 2. Okay, and multiplied with 1 by 3 root 2 plus, so the sixth term will be equal to what, 2 by 3 root 2. Okay, now if you solve this and compute the result, you'll basically get this result as 6 into, so this particular result will yield as, okay, so if you solve this, the result will be basically half. Okay, so this will be half and multiplied with, and this result will be equal to 1 by root 2. Okay, so you can definitely check out, this is basically directly equal to 1 by root 2, because 3 and 3 get cancelled, 1 by root 2, and this result is also equal to, like this will be 3 by okay, so this will be 3 by 6 root 2, so 1 by 2 root 2, so that is basically equal to 1 by 2, and 1 by 2 into 1 by, so this is like 1 by 2 root 2, and this result will be equal to 1 by root 2. So now you can definitely take this and write the value as, okay, I hope there is no an error of my side. Okay, so from here you can definitely solve this and the value will be equal to 3. Okay, I hope, okay, I did a mistake maybe. Okay, so there is like a 2 over here. Okay, and yeah, rest are pretty simple. Okay, so if you compute the result, you will get the result as value is equal to 3. So from here, the right answer to this particular problem will be equal to option number D. Okay, will be equal to option number D. I hope you have understood this particular problem and you can definitely try and you got the same answer as of mine, that is option number D. Okay, so pretty simple problem to be very specific. Okay, but still I took this problem because many times you'll see that the problems of GP get repeated. Okay, and these are the very important problem set of GP that actually get repeated in examination, because you will get a GP with basically different condition, and you, based on this condition, you need to find for the values. Okay, so that is basically different types of problems that are actually asked in a paper. So with this, let us move to the next problem. And the next problem, it says that, so if you have S1, S2 and S3 and all up to S10 respectively with the sum of the 12 terms of the 10 APs. Okay, so if you have 10 APs and the sum of the 12 terms of those 10 APs are basically S1, S2, S3 and as so on up to S10, and all the APs whose first terms are basically, so the 10 APs are there, and each of the 10 APs has first term as 1, the second AP has first term as 2, the third AP has first term as 3 and so on up to 10. And similarly the common difference are as 1, 3, 5 and 19 respectively. Now you have to basically sum up for this particular value. Okay, so this is a fairly very important problem. Okay, but an interesting problem, to be very honest. Okay, now let us check that we basically have 10 APs. Okay, so we have 10 arithmetic progressions. Okay, so we have 10 APs and whose first term with first term, okay, first term as equal to a of I. So the first term has a of I and the common difference is d of I. Okay, so the first term has a of I and the common difference is d of I. Now if you look at the first term of the AP are basically is equal to I. Okay, so the first term of each of the AP is equal to I. So for any of the ith AP, the first term will be equal to I. And similarly, if you look at the common difference of the ith AP, that is basically this particular values, that is 1, 3, 5. So if you observe, these are also again in AP with a common difference of 2. That means this AP, if you try to express this number, these are basically odd numbers. Okay, and odd numbers. So you can write this AP or the common difference of each of the AP are also in AP, and that is basically equal to. So you can write this in terms of I, that is 2I minus of 1, that is the odd number. Okay, all right, so this will be 2I minus of 1, and yeah, it is okay. So these are the numbers which basically will be the AP. Okay, which are also in AP. So we got the common difference of each of the AP. That means the common difference of the ith AP will be equal to 2I minus 1. Okay, now I have to look for what is the sum of the ith AP. What is the sum of the ith AP? So if you have studied the formula for the sum of the AP, that is basically equal to, so that is equal to n by 2, okay, divided by multiplied with a plus n minus 1 into d. Okay, oh very sorry, sum of the first term and the last term, so that is equal to a plus, okay, so that is equal to sum of the first term and the last term. Okay, so that is equal to that is equal to 2 times of a plus n minus 1 into d. So that will basically be the sum of the ith AP. Now if you compute the value for the sum of the ith AP, so let me do so. So we need to sum the AP. Okay, we will have basically in each of the AP there are basically 12 terms. So each AP, okay, has 12 terms. Okay, so each of the AP has 12 terms. So if you look at the sum of the, so for the sum of the 12 terms for each of the AP, so that is basically equal to 12 by 2 whole multiplied with 2 times of AI plus n is basically 12, and that is equal to 11 times of, that is equal to 11 times of di. Okay, and if you simplify, this result is equal to 12 into ai plus 66 into di. Okay, that is 12 into ai plus 66 into di. Okay, so that is the sum of the 12 term of each of the ith AP. Now we have to basically, in the problem it is said we have to compute for the result, that is sigma I is equal to 1 up to 10, that is s of I. Okay, s of I. Okay, so that is the value that you need to compute for the result. And if you look at this result is nothing but the summation of I is equal to 1 to 10. Okay, so the summation I is equal to 1 to 10, and if you look at the individual summation of the 12 term, it is basically 12 ai plus 66 di. Okay, so now if you take the constant out, so that is 12 times of summation of ai, and where I is basically 1 to 10 plus 66 into summation of I, where I belongs to 1 to 10, that is summation of di. Okay, so if you have studied the properties of summation, you can definitely take out the constant and write like this, and this will be basically equal to 12 into, so what is the sum of the first 10 natural numbers, because ai are basically 1, 2, 3 and all, so the first 10 natural number is basically, so that is 10 into 11 divided by 2. And for this particular number, so if you look at this number, is basically, so di is basically again equal to 2I minus 1, and ai is basically equal to I, so that is the first sum of the first 10 natural numbers, that is basically equal to 55. And similarly if you look at di, that is basically 2 times of the sum of the first 10 natural numbers, that is basically 10 into 11 divided by 2 minus, and for 1 this is constant, so 1 is basically added 10 times, so that is minus of 10. Okay, so this value will equal to that is 110 minus 10, so 110 minus 10 is 100, so that value is equal to, so if you cancel this result is with 6, so this will be equal to 660. Okay, and plus this result will be equal to 6600, and if you sum up, the result will be equal to 7260. So if you sum this result, the result will be equal to 7260. So with this, the answer to this particular problem is equal to option number C. I hope you have got this particular problem. Pretty interesting problem, okay, but still many students actually get confused, like how to assume the ith term of the each of the AP and the common difference of the each of the AP, okay, and how to take the summation of the 12th term of each of the AP. So these are the very important concepts that I wanted to take all of you. Okay, this is a tricky and interesting problem. Okay, still students get confused in this types of problems, so I hope you won't get confused from the next time you solve this particular problem. So with this, let us move to the next problem, and the next problem is basically said that there is a sequence. Okay, now instead of telling what is the type of sequence, it is telling you that let an be a sequence such that, okay, where, so an be a sequence, okay, it is basically saying that this is a sequence, okay, where a1 plus a2 and so on up to an, okay, and so on up to an is equal to n square plus 3n whole divided by n plus 1 into n plus 2. Okay, so it is saying that the such an a sequence is given whose summation up to the nth term is equal to n square plus 3n divided by n plus 1 into n plus 2. Okay, and if it is saying that if the value of the 28 times of summation of k is equal to 1 to 10, 1 by a of k is equal to p1, p2 and so on up to pm, okay, where p1, p2 and p3 are all basically the first m prime numbers, that is first m prime number, that is 2, 3, 5, 7, okay, 11, 13, 17 and so on. Okay, so then what is the value of m is equal to? So if you look for the value of m, okay, all right, so fairly simple problem, okay, but there is also there is concepts involved in it. Okay, so instead of giving a sequence which is basically not very known to us, instead they are giving a sequence which is basically of this particular format, then how to get to the first term? Okay, so if you know this particular, if it is a sequence, then you must follow some kind of a condition, and that particular condition, if you look for the, so if I say that what is the value of sum of the nth term minus sum of the n minus 1th term, you will say that it is equal to the last term. Okay, that is equal to the last term, that is a of n. Okay, so if we use this particular result, because for any sequence, okay, for example, for any sequence which is present out, it must follow or satisfy some condition, and we are given with the condition that is the summation of the nth term, so that is s of n. So if you are given with s of n, then in place of n, if I put change with n minus 1, I will get the summation of n minus 1 term. Alright, so with that, if I take the difference, I will get the last term. Okay, so if I have the last term, that is a an sequence, I can definitely say that the kth sequence will follow a given condition with a condition that on a number that is n. So let me find the nth last term, okay, or the a of nth term or any of the general term. To be very specific, okay, because once we get to the general term, then we basically understand what is the general condition that is satisfying. Okay, so if we look for that is the s of n value, so the s of n value is basically n square plus 3 of n. Now this is true for any progression, this is true for any sequence. Okay, this is also true for any sequence. So then if you compute the result, that is n1 multiplied with n plus n1 n plus 2 into n1 plus 1. Okay, and then you take the subtraction, in place of n you put n minus 1, so this will be n minus 1 whole square plus 3 times of n minus 1 whole divided by n into n plus 1. Okay, now this value is equal to a of n. Now let us solve for a of n. So if you apply this particular result and if you solve for a of n, you will see that the a of n value, so you can simplify. Okay, let us simplify, that is n square plus 3n divided by n plus 1 into n plus 2, and if you subtract it, let us simplify this result. This result will be n into n plus 1, and the upper result will be basically equal to n square, and this is basically minus of 2n, minus of 2n plus 3n is equal to plus of n. Okay, plus of n, and that is plus 1 minus 3 is basically minus of 2. Okay, plus 1 minus 3 is equal to minus of 2, and now if you take the common, that is if you take 1 by n plus 1 as common, okay, 1 by n plus 1 as common, then you basically get the result as n square plus 3n, okay, whole multiplied with n divided by n plus 2 multiplied with n minus n square plus n minus of 2 whole multiplied with n plus 2. Okay, now you can definitely simplify these results. Okay, so that is the value of sn minus 1, that is the nth term of this particular sequence, and that is basically, if you solve this result, you will get it the result as 4 divided by n into n plus 1 into n plus 2. So you get the sequence as n into, so 4 divided by n into n plus 1 into n plus 2. Okay, so that is the sequence or the nth term. Okay, this is basically the nth term of the sequence. Okay, so that is the nth term of the sequence. Now in the problem, it is basically asked to find out, that is 28 times of the sigma k belongs to 1 to 10, 1 by a of k. So if you compute this result, is 28 into sigma k is equal to 1 to 10. So now you take the reciprocal of this nth term, so that is in place of n you put k, that is basically equal to k into k plus 1 multiplied with k plus 2 whole divided by 4. Okay, and that is the expression that we need to evaluate. And if you take 4, because it's a constant, so if you cancel out with 4 and 28, that is 7 times, that is equal to 7 times of sigma k is equal to 1 to 10, that is basically equal to k into k plus 1 whole into k plus 2. Now you must know how to solve these types of problems. Okay, now you can definitely solve these problems by multiplying with so if you have studied the sequence series, you basically need to solve these questions by multiplying with the one term ahead and then subtracting or taking a common difference. Okay, taking by common difference and then cancelling out the required terms. Okay, so you can definitely do so over here as follows. Okay, what I will try to do over here, so for computing this particular result, what I will do, so let me write this particular result of k belonging to 1 to 10, that is k into k plus 1 into k plus 2. Now there is another method of solving this problem as like go on multiplying. Okay, if you go on multiplying, this value will be sigma, so 7 times of sigma k square plus k whole multiplied with k plus 2. Okay, now if you compute this result, this will be again equal to, so you can try this is k cube plus 2k square and k square, so there will be equal to 3k square plus the last time will be equal to 2 times of k. Okay, so that is a sigma, and if you put sigma on each of the terms, okay, now if you put sigma on each of the term, you can definitely simplify. Okay, and this will be fairly simple. Okay, you can directly simplify. Also, there is another approach to solve this particular problem is just by multiplying. So for example, if I take this number, I can do this, that is k into k plus 1 into k plus 2, and then what I do, I basically multiply with k plus 3 and then subtract the term as k minus 1 into k plus 1 into k plus 2. Okay, and since I did this, I basically need to divide by a factor to neutralize this term, that is 1 by 16. So now you basically get to this particular term as the same as value of this particular term. Okay, and if you do this, you'll basically get a telescopic sequence, or the terms can be written in a like a fashion of a subtraction. Okay, added in a fashion of a subtraction fund, and the terms go on cancelling. Okay, and you will be left out with the result, okay, which is basically directly equal to, and you can directly form this result, and that is basically equal to n into n plus 1 into n plus 2 whole into n plus 3 minus the first term, okay, and whole divided by 1 by 16, that is the first term, and minus the first term. Okay, and if you put the first term value, that is basically k 0. Okay, because if you put k is equal to 1, this value is equal to 0. Okay, and similarly, if you calculate this, you will basically get to the result by putting n is equal to 10, and similarly, if you put over here also, that is if you sum up these k values for the, like using the formula that we have studied, that is the summation of k is basic for up to n is basically n into n plus 1 divided by 2. Similarly, the summation of k square for up to n term, that is basically equal to n into n into n plus 1 into 2n plus 1 whole divided by 6, and similarly the summation of the k cube term is basically n into n plus 1 divided by 2 whole square. Okay, whole square. So these are the results you can definitely apply, and if you compute the result by this application of this particular formula, you will get the value which is simplified out as, so I have solved this on my own, you can definitely solve this. Okay, you just need to calculate for the computation and multiply it. Okay, so you will something get the result as, okay, now I have did this by this particular method. Okay, I did this by this particular approach. So if you do this particular approach, you will get this result something as of that. 28 into 1 by 16 into the result was coming out as 17160. Okay, and if you simplify, this is equal to 30030. Okay, so 30030, and that is basically we need to express as P1, P2, and so on up to Pm. Okay, so if you look at the factorization of 30030, and in prime factorization of this is basically the prime factorization of, so this is equal to prime factorization of 2 into 3 into 5 into 7 into, okay, 7 into 11 into 13. Okay, so if you do this prime factorization, this will be the prime factorization of 2 into 3 into 5 into 7 into 11 into 13. So very important number. So you see how the beautiful number it is. It is taken as a product of the consecutive m prime numbers. Okay, so if you look at this number, this is a wonderful number in itself. Okay, that is the product of the m prime numbers. Okay, and if you see the prime number has power of each of the power or indices is basically 1. So how beautifully the problem is actually framed. And with this, if you look at these values, so this is the first prime number, second prime number, third prime number, fourth prime number, fifth prime number, and sixth prime number. So with this, the answer to this particular value of m, that is, if you look for the p of m, that is the pth prime number, pth first prime number. So first m prime number. So that is the value of m is equal to 6. And with this, the right answer to this particular problem will be option number C. I hope if you have tried this particular problem, you must have got the same answer as of mine. Alright, so with this, let us move to the next problem. And the next problem is again a fairly simple problem, again which involves a concepts which is very important that you must remember for different problem solving. Okay, on the next time. So it is also a problem which basically need to compare for the inequality, that is AMGM inequality. So if you know the inequality, so the inequality says that AM is greater than or equal to GM, and this equal to exists when the numbers are equal, and greater than or equal to HM, that is harmonic progression of these numbers. So if I take the numbers, okay, so if it is given in the question, it is mentioned that is A plus B plus C plus D is equal to 11. Now I have to look for the maximum value of this particular set of numbers. Okay, so if you look at the number, that is basically A5, B cube, C square, and D. So what I am teaching in this particular approach is a very important thing that you must remember. Now when I will get A5, A5 is got when I consecutively go multiply A and 5 times. That means instead of like multiply in this particular fashion from A, if I write this as A by 5 plus A by 5 plus A by 5 and so on up to like 5 times of A by 5, okay, this will be equal to A. And similarly, if I take B as B cube is given over here, so similarly if I write the B as B by 3 plus B by 3 plus B by 3 in this fashion, and similarly C square is given over here, so if I write C as C by 2 plus C by 2 plus D is equal to 11. Now if I take all these particular numbers, that is there are total 5 over here 3, that is 8, and 8 plus 2, that is 10, and 11. So there are total 11 numbers, and for these 11 positive numbers, if I apply, and for these 11 positive numbers, okay, so I'm writing over here, so for these 11 positive numbers, now this is very important, you will see in the previous JEE advanced problem also this types of problems was actually repeated many times. Okay, so that's what is the importance of this particular problem, and I took this problem because I see that this types of problem actually get repeated many numbers of times. So the concept is very important, and if I see that these are the 11 important positive numbers, okay, now then by inequality, so then by AMGM inequality, so if I apply the AMGM inequality, so if I apply the AMGM inequality, so what will I get? So the summation of the numbers of the which is present on the AM term is basically again equal to, overall if you sum of these numbers for 5 times of, okay, let me write this for your simplicity. Okay, so this will be basically 5 into A by 5 plus 3 into B by 3 plus 2 into C by 2 plus D, and whole divided by total number is 5, which is basically greater than the GM, and GM will be equal to A to the power 5 divided by 5 cube power 5 into B cube whole divided by 3 cube and C square whole divided by 2 square into D, and whole raised to the power 1 by 11. Now if you solve this, the result will be basically the AM term is equal to 1, and this will be greater than or equal to A to the power 5 B cube C square. Now why did I do so? Why did I express the number as a summation of these 11 numbers? That the fashion is basically and when I write this particular numbers in this particular fashion, okay, in this particular fashion, I got the GM value as a required value, that is A to the power 5 B cube C square and D. Okay, now the advantage of writing the numbers in this particular fashion was to basically to obtain the required number, because in the question we have need to look for the maximum value of a to the power 5 b q c square into d. Okay, so if I have to do this, then I have basically have this express the numbers in form of 11 numbers, and in 11 numbers expression I basically got the values as, okay, I basically got the values as this particular value, and when I compute the gm value I got this gm as the required result which is asked in the problem. So that's what my intuition to solve this particular problem, by which, okay, so I hope you got the intuition like why did I need to approach this particular problem in this particular fashion. Okay, and if you do so, then you will find this and divided by 5 to the power 5, 3 to the power 3 and 2 to the power 2. Okay, whole raised to the power 1 by 11. So what is the maximum value of a to the power 5 b cube c square and d will be basically less than or equal to. So you have to do this by taking the like expressing the number on both the side to the power of 11, and if you do so, this will be basically will be equal to 5 to the power 5, 3 to the power 3 and 2 to the power 2. And if you solve this result, okay, so you can definitely solve this result as, so if you calculate the result, okay, so this is basically, so 5 to the power 5, okay, and this result was basically given as 3750 into beta. Okay, 3750 into beta. So if you look for 3750, okay, so beta value basically equal to 5 to the power 5, 3 to the power 3 and 2 to the power 2 divided by 3750. So what I do is basically go on consecutively dividing, okay, and you can definitely solve this on yourself as well. Okay, so if you solve this and like evaluate the result, so you can do this. Okay, like if you cancel out with 5, this will be basically equal to 7, and you carry 2, this will be 750, and 5 get cancelled with the 4. Okay, similarly again you divide by 5, so this will be basically equal to so this is basically equal to 170. Okay, and similarly again you divide by 5, so you divided by 5, that means this is 3, and similarly again you divide by 5, this will basically equal to 34, and this is 5 square, and similarly 34 is given over here, so if you divide by 2, this will be basically equal to 17. Okay, so I hope you can, and then you can definitely approach it. Okay, if not any mistake is present from my side. Okay, so actually yeah, there is a mistake. Okay, there is a mistake, so this is not equal to 70. Okay, so if you divide by 5, this is basically 150, and then again divide by 5, this result will be equal to 30. Okay, and then again divided by 5, so or you divide by 2, this is 15. Okay, so there is a 2 get cancelled, and similarly divided by 5 again. Okay, so 5 again, this result will be equal to 3, and similarly 3 if it cancel it is 2, and similarly if you solve this result, the result is 9 into 5 into 2, that is 90. So the result will be equal to 90. So the value of the beta will be equal to 90. So if you solve this result, the value of the beta will be equal to option number C, that is 90. So I hope if you have solved this particular problem before than me, then you must have got the answer as option number C, that is the value is equal to 90. I hope this approach is very important. The concept which I used in this particular problem is very important. What is that concept of like expressing the numbers in this particular fashion? Now in doing so, I got the required result, that is the expression, that is a to the power 5 bq c square and d. So I hope you will understand and remember these results. Okay, now this is very important result. So it is better to remember these types of concepts whenever these types of problems actually come up in the examination. I hope you will do so, and with this let us move to the next problem. Alright, the next problem says that we have x1, x2 up to x100 are in arithmetic progression with the first term x1 is equal to 2 and their mean is equal to 200. Now they are defining another sequence whose ith term is given by I into xi minus I, where I belongs from 1 to 100. So you have to look for the mean of y1, y2 up to y100. Alright, so this is an interesting problem in itself. Now how we will basically approach this particular problem is firstly get to the arithmetic progression what x1, x2, x up to x100 actually follows. So if you look at the mean, the mean is actually 200. Okay, now if the mean is actually 200, that means basically you basically have 100 terms, and the sigma xi divided by 100 is equal to 200. Okay, now from here you can definitely say that whenever it is basically summation of an AP, and sum of an n terms of an AP is basically given by this formula. So summation of n term of an AP is given by the formula, which is, let me write it clearly. Okay, so it is given by n by 2 whole into 2a plus n minus 1 into d. Also, this can also be written as n by 2 into the first term, okay, plus the last term, okay, and that is basically the sum of the n terms of an AP, okay, sum of the n terms of AP. Now, if I do that in the following problem, okay, now if I apply that same principle of the, okay, so this is 100 terms, so 100 by 2, 100 by 2 multiplied by 2 times of first term, which is basically 4, plus 100 minus 1, that is 99, into the common difference. So let us assume the common difference is d, and this is basically, if you cross multiply, the value will be equal to 200, okay, so this will be equal to 20,000. And now from here, if I solve, okay, so now from here, if on solving, we can simplify this and we'll get it as 4 plus 99 of d is equal to, so you can definitely cross cancel out, so 2 zeros, that is 200 by into 2, that is equal to 400, okay, so that will be equal to 400. All right, so from here you'll basically get the value of d, and the value of d is basically, so 99d is equal to 396, and if you cancel this 396 with 99, it is basically 4 times, okay, so you can definitely see this is actually 4 times. So from here the value of d is equal to 4. So you got an AP whose common difference was actually equal to 4, and the first term is given as 2. Okay, now we basically need to look for what is the sequence, that is yi. So also it is given in the problem, that is yi is equal to I times of xi minus of I. Okay, now where I belongs from 1 to 100, okay, so I value ranges from 1 to 100. Okay, now that is basically yi. So if you look for what is yi, so let me check and let me write it what yi actually means. Before writing yi, I can definitely write xi as, okay, now xi basically has a terms of an AP, so this can be written as first term, that is equal to 2 plus I minus 1, because we are writing for the ith term, so I minus 1 into d, so common difference is equal to 4, and that will basically come out as 4i minus of 2, so that is xi. And from here the yi value will be equal to I multiplied with xi. Xi is actually equal to 4i minus 2 minus of I. So if you do this simplification, this will come out as 3i square minus 2i, 3i square minus of 2i. Now I have to look for what is the mean of yi's, okay, so I have to look for the mean of yi's, and there are actually 100 terms of yi's, so that is basically equal to 1 by 100 times of summation of yi. Okay, so that is the mean of yi. So if I am writing the mean of yi as y bar and the mean of x bar as something like that, also then from here I can definitely write this as, that is 1 by 100 times of, now this will become equal to sigma, where I belongs to 1 to 100, and that is equal to 3i square minus sigma I belonging to 1 to 100 2i. Okay, so if you simplify this result, that is 1 by 100 times of, now 3i square, so you can write this as 3 into 100 into 101 into 2 times of 2 into 100 plus 1, that is 201, divided by 6 minus 2 times of, that is 100 into 101 divided by 2. Okay, so if you simplify, you can cancel out this, like, okay, you can cancel the terms, and definitely on solving you will find out that if you divide by 100, the summation that the result or the mean, that is y bar, will actually come out. You can definitely solve it on yourself, okay, and tally the result for with mine. So I got the result something as 20301 divided by 2 minus 101 by dividing by 100. Okay, so I actually divided by 100 and got this particular result. So with this the result will be, if you calculate this again, so this result will be equal to 10049.50. Okay, so if you can calculate, this result will be equal to 10,049.50. so that's the required answer of this particular problem, and with this the answer will be option number B. I hope you have got this particular problem. Okay, now this problem was actually important. Why? Because it gave you information about one sequence and it asked you information about the other one, so you can understand like how easily we can definitely solve for the other one by just getting out the xi. Okay, so that was an important thing. Now with this, let us move to the next problem, and the next problem is again a very important set of problems that actually like asked many times in examination. So this is a problem on, like, if you have studied about like AGP. Okay, and we basically actually try to solve this problem by method of common difference. So if you see this problem, it is also a problem where it says that you have an Sn given as, the sum Sn is basically given as 4 plus 11 plus 21, and so on up to, okay, plus 34. Let me write some more terms up to the n terms, okay. So it is saying in the question in some like this particular fashion, okay. So we have to look for the summation value, okay. So what I can write, what I will observe that if I subtract 4 from 11, if I subtract 4 from 11, so let me observe what is the common difference of 4 from 11. So what I see that this difference is equal to 7, and similarly if I subtract 21, okay, so from here the subtraction is basically equal to 10, and similarly if I subtract these terms, okay, 21 from 34, this is equal to 13. Now if I do subtract this 7 and 10, I will get the value as 3. Similarly 10 and 13 is equal to 3. That means the differences of the consecutive terms for this SN are actually in AP. Okay, so that is a very important conclusion that I got from here. Now how to do this, how to solve this particular problem? I first assume, so from here I will assume the SN to be equal to 4 plus 11 plus 21 plus 34 plus 50 and so on up to, okay, so on up to the nth term. So let me represent the nth term by Tn. So Tn actually represent the nth term, okay, nth term of the sequence. All right, so the nth term of the sequence is Tn. Now I can also write Sn over here, and instead of writing 4 in this particular position, I just shift one term in the to the right and write like this. This is 4 plus 11 plus 21 plus 34 and so on up to, and with this the term over here that will come, that is Tn plus 1 plus of Tn. Now if I subtract both these equations, so if I write this as first value and the second value, so what is the advantage of doing C? I will get it as this result. So if I subtract these results, okay, so if I subtract these results, what I will get? I will get the result. So I will get this over here on the left hand side is equal to 0, and the result I will get it over here is basically 4, and this value will be equal to 7 plus this value will be equal to 10 plus 13 and so on up to the term that is Tn minus 1. And what is the advantage of doing so? That is these terms what I am highlighting over here, these all terms are actually in AP, okay. So these all terms are AP, and that is what the advantage we got from here. So in looking for the sequence, we basically take out the difference between the consecutive terms, and whose difference also we take out, we basically found that difference were actually constant. That means the difference of the consecutive terms were actually in AP. Okay, so and on solving this we basically will get, so let us take the Tn on the left hand side. So Tn is equal to, so I will get the nth term as equal to 4 plus 7 plus 10 plus 13 plus whole up to, so there will be basically equal to n terms. Okay, so if you look at why there will be n terms, so if you see from here, from this particular term to the Tn term there are n minus 1 term, and similarly from 4 to Tn minus 1 there will be n minus 1 term. So that means these all values will constitute n minus 1 terms, and including 4 will include actually n terms. I hope this thing is clear, because not everyone actually explain this particular things, okay. Even if you study the books, you won't actually get that why actually it is n term and why it's not n minus 1 term, because many students actually have confusion in taking the summation up to n terms or summation up to n minus 1 term. So I hope you have cleared that particular doubt, and with this you will get the Tn value is equal to, so this is basically an AP, and if you look at the AP will basically of n terms is equal to summation of the n terms of an AP is equal to n by 2 into the first term into 2, that is 8 plus n minus 1 into 3. Okay, now if you solve this, you will get the result as 3 by 2 n square plus 5 by 2 n. Okay, so if you look at this, then you will get the general term or the nth term, general term or whatever you say, that is the nth term. You will get it as 3a by 2 n square plus 5 by 2 n. And if you have the nth term, then I can definitely say that summation Sn is basically summation of the nth term or the general term of where the n value basically belongs to 1 to n. Okay, now in the problem it is asked for S29 and S9. So let me calculate firstly S29. So if I calculate for S29, this will be sigma where 1 to 29, the sigma limit will go up, and it will be 3 by 2 n square plus 5 by 2 n. Okay, so let me, okay, and if it is n, so this is n 1 to 29, and if you calculate this particular result, you can definitely calculate it as, okay, so before doing so, let me firstly generally calculate it, and then later put the values. So from here, if you generally calculate the value, this will basically equal to 3 by 2, and the summation of the first 10 natural numbers, that is basically, sorry, square of the first 10 natural number, that is basically n into n plus 1 into 2n plus 1 whole divided by 6 plus 5 by 2 into n plus 1 by 2. Okay, now you can put the value of 29 for S29 and put the value of n as equal to 9 for S9. And on calculating, okay, so you can definitely do this calculation. Okay, this fairly simple calculation. Okay, so on doing that, if you put n is equal to 29, you'll find the value. Okay, and similarly n is equal to 9. Now I have to basically get for the value that is S29 minus S9. Okay, so S29 minus S9. So if you calculate this difference, okay, and then multiply it with 60, 1 by 60. Okay, so you can definitely do this calculation, and I have done that calculation on my own. All right, so you can do this calculation, that is S29 minus S9 and whole multiplied with 1 by 60. You can definitely perform this calculation, simple calculation. Okay, just put n is equal to 29 for S29 and n is equal to 9 for S9, and then you will find that there are some common factor that will be coming out, and once you take the common factor out, you will definitely get it cancelled with 60, and the result you will definitely find out as is basically that what I got as 223. I hope you will got the same result as 223. I have solved this on my own. Okay, so with this, the right answer to this particular problem will be basically equal to option number D. So if you have solved this particular problem and also have got the option number D, so you can again encounter a +4 to your bucket. Okay, so that's a pretty simple problem, and I hope you will understand these types of problems and how to solve these types of problems. Okay, because not every time you are going to encounter problems with a given sequence whose actually general term or the summation you actually know every time. So alright, so that was a fairly simple problem, and with this let us move to the next problem, and the next problem is again a problem of an GP. Okay, so let us understand this problem, what it says. So it says that the first term is alpha and the common ratio r of a geometric progression be the positive integer. So both of them, alpha and r, are positive integers. Okay, now if the sum of the square of its first three terms, okay, sum of the square of this first three times is equal to 33033, then the sum of the three terms is equal to what? So if they are in GP, okay, if there is a GP which first term and r are the common ratio and the first term alpha, so what we can write, the if the sum of its first three terms, okay, so the first three terms square, that is alpha square plus alpha r whole square plus alpha r whole square, alpha r square ka whole square, is basically equal to 33030. Okay, so that is basically mentioned in the problem by the sum of the first three times, sum of the square of the first three terms of the GP. Okay, now if you calculate this, what you can do, you can take alpha square as common and you will get the result as 1 plus r square plus r to the power 4, and that is basically equal to 33033. Okay, so that is the result from here I am getting. Now it is also said that both of them are positive integer. Okay, now the problem is basically that students actually encounter coming over here. Now what to basically do after this particular step? Okay, they actually don't get any idea or hint how to basically obtain from this particular like equation who has two actually variables and only one equation is there. So you have to solve this particular problem by using your maths knowledge. Okay, so that is basically a proper like of mathematics knowledge. So you can just go on putting the numbers and go on checking. Okay, so that will basically require time. Okay, so you can see that this is alpha square plus 1 plus r square plus r to the power 4 is equal to 33033. Okay, so that is the value. Now what I can observe from here, now if you look at these values, okay, now if you look 330 and 33, that is basically you can write this as fine factorization as 3 into 7 into 11 into 11 into 13. Okay, so you can write this as a summation of this particular value. So this value when we factorize as in this particular fashion. Okay, so you can factorize this 33033 as 3 into 7 into 11 square into 13. Okay, and on doing so, what you observe is that 11 square is there, and this is a number, positive number, and this is a square number. Okay, square of a number. So what I can compare on this, that is alpha square is equal to 11 square. So from here I'll get the value of alpha as 11. Now once I get the value of alpha as 11, what I will remain with, what I will left with, that is 1 plus r square plus r to the power 4 value is equal to like 330033 divided by 11, and that value basically equal to 272. And once you get over here 272, then you can definitely solve this particular problem by the quadratic approach. Okay, or you can see that this is a biquadratic equation, and definitely you can get the roots. Okay, so that's what is the intuition that you need to look for. So whenever there is an equation involving one equation and multiple variables, so there are some ways to basically solve those particular equation, and that actually comes from intuition or practice. Okay, And this is basically intuition. What I did is basically I factorized this number, and on factorization what I found out that there is a square of a number that is 11, and once I got the square of a number 11, I found that this is basically which resembles to this product of one square and another positive number. Okay, so that particular square number is basically equal to 11 square, and I equated them and I get the value of alpha. Once I get the value of alpha, I got the other product value is equal to 272, and from here I got a biquadratic equation. Okay, sorry, 273. All right, very sorry, very sorry. So this value will be equal to 273. Okay, this value is actually equal to 273. Okay, so from here I got a biquadratic equation, that is r raised to the power 4 plus r square plus 1 is equal to 273. So from here the equation that will be basically equal to r to the power 4 plus r square plus 272 is equal to 0. Now you can factorize these particular values as r square. Okay, the one of the root will is mine. Okay, of r square value will be factorized as 17, and so 17 and 16, you can see this is 16 square is 256 and 17 into 16 is 272. So you can factorize as r square plus 17 and r square minus 16 is equal to 0. But since it is given that r is a positive real number or integer of course a real number, so this cannot be 0. So that means this is always a positive number, and this is equal to 0. That means from here I will get r square equal to 16 and r is equal to 4, because r is a positive integer. So from here r value is equal to 4. Now once I get the value of r as 4, I can definitely put back I have got the value of alpha. Now I have to look for the sum of the first three terms. That means I have to look for alpha plus alpha r plus alpha r square. So what is the value? That is alpha is I got at 11. So I take out 11, 1 plus r value is 4 and r square value is 16. So this is basically equal to 21 into 11, and that is also equal to 231. Okay, so that is equal to 231. So with this, the right answer to this particular problem will be basically option number B. Okay, so I hope if you have solved this particular problem, you must have got the answer as option B. Fairly simple problem, but I took this problem because many students actually encounter problem difficulty in solving this particular step. Okay, in this particular step is actually an important step, like how did I had that intuition of getting into factorization. Okay, so I hope you will understand this particular method and keep it remembered for the next time when you encounter these types of problems. With this, let us move to the next problem. And next problem is again a sequence problem. Okay, so I would request all of you to basically solve this particular problem as a homework problem from your end. Okay, I will definitely give a hint, but I want all of you to get to the answer and definitely comment me in the comment section with the right answer to this particular problem. And also you can also explain me the steps you basically took to actually get to this particular problem. Okay, I'll be very happy to receive your comments. So with this, let us understand, like get a hint, like what is the summation I'm talking about. So if it is saying that a and b the nth term of the series, okay, so there is a sequence of series which is given something like this, and a and b is the nth term of it, such that Sn is basically the summation of the a k term, where one k belongs from 1 to n. That means the summation of 5 plus 8 plus 14 plus 23 and so on up to the nth term. Okay, plus let me write some more terms. So what I can observe is that again, if you see this difference of this 5 and 8 is equal to 3, and similarly if you see the difference is equal to 6, and similarly this difference is equal to, so if you see this difference is equal to 9, and similarly again if you see the difference of the differences basically is equal to 3, and see difference also equal to 3, that means the differences of this particular sequence are also are in AP. So this is again a very similar problem, okay, to the problem which we basically encounter, that is S29 minus S9. So I hope you remember that problem. Okay, so there is a very similar type of problem that is basically took up. Okay, so I hope you can definitely encounter, if you can solve this particular problem, if you were comfortable solving that particular problem. So I left this particular problem up to you. Okay, now also if you want to learn about the shortcut of how basically we can, instead of like solving in the form of getting an AP and then solving for the nth term, you can also write a shortcut method. Okay, so I can teach the shortcut method in one of our short videos. Okay, so I would be very happy if you can comment me that do you need that particular shortcut video or not. So I will be looking for your comments as well. So I can teach the particular shortcut method to just directly write the Tn term from here. Okay, from here you can definitely write the Tn term. Okay, so wait for my shortcut. So with this, let us move to the next problem, and the next problem is again a important problem. Okay, I took this problem. Okay, let me understand and explain this problem to you. So it is saying that there is a sequence of sk, and it is saying that it is 1 plus 2 plus up to the kth term and whole divided by k. So if you calculate this result, you will find it as k into k plus 1 whole divided by 2k. That means basically equal to k plus 1 by 2. So sk is basically equal to k plus 1 by 2. And also it is given that if we found out sk is basically k plus 1 by 2, and it is said that j belonging to 1 to n sj whole square is equal to n by a into bn square plus cn plus d. Okay, so where a, b and c and d are all natural numbers, so then we have to look for a has a least value what, and we have to basically find out the value. So if you look at the options, you basically need to find out the value for a, b and c and d. So from here, what I can approach this particular problem by, so I can do this particular problem as an approach. Okay, so from here, if you look at this particular problem, this is j belonging to 1 to n, so sj is basically, so that is j plus 1 by 2, so that will be basically j plus 1 by 2 whole square. And if you look at this particular value, this will basically summation j1 to n, this will be equal to j square. So if you can take 1 by 4 common out of here, because it is a constant term, it will be coming out of the summation, that is j square plus 2 times of j plus 1. Okay, now you can definitely solve this particular result. So if you put the result back by the formulas, okay, so the result will be basically 1 by 4 times of n into n plus 1 into 2n plus 1 divided by 6 plus n plus 2 times of n into n plus 1 by 2. Okay, and this value, it is basically given as, so you can simplify these results. Okay, this value actually given out as, it is actually given in the problem as like n by a, it is given as n by a into bn square plus cn plus d. Okay, now if you can simplify these results, I can leave out the simplification to you. Okay, this is fairly simple simplification. Okay, so if you simplify the results, you'll get the result as n plus 1 into 2n plus 1 divided by 6 plus 1 plus n plus 1. Okay, and whole divided by n by 4 whole multiplied with n by 4. I took out just n common from this particular bracket, and again if you simplify, the result will be basically n by 24. Okay, and the result will be basically 2n square plus 3n plus 1 plus 6 plus 6n plus 6 plus 6. Okay, and if you simplify, this result will be basically n by 24 into 2n square plus 9n plus 13. And on comparing, you will find out the value of a is equal to 24 and b is equal to 2, c is equal to 9 and d is equal to 13. Okay, now if you can put back the values of a, b and c and check for the results, you will find out that option number that is, so the right answer to the particular problem, if you can find out with putting the values of a, b and c back, you'll find that option number d is basically the true value. Okay, that is a true thing. That is saying that a plus b is actually divisible by d. Okay, so you can do this on yourself. Okay, so I hope you will get the result from here. And with this, let us move to the next problem. All right, so the next problem is on your screen. All right, so it says that GCD, okay, or GCD, or basically if you call it as HCF, is basically equal to 1. So basically m and n are co-prime number. That's what this particular significance has it. And then it is talking about 1 square minus 2 square plus 3 square minus 4 square and so on up to plus of 221 whole square minus 222 whole square plus 223 whole square. Okay, so by this you can assume that it is a 2023 previous year questions. Okay, now this type of problem is actually asked back long back in JEE Advanced. Okay, so if you look at the JEE Advanced previous year questions, you can definitely encounter this similar kind of problem with n and n minus 1 as the last two terms. Okay, now how to solve this particular problem? I took this problem just to explain you a very important thing that you will basically get it when you solve this particular problem. So if you take the two consecutive terms, whatever you take 1 and 2, 3 and 4, and even 221 and 222. Okay, so if you look at these terms, okay, and if it is said that this summation is basically equal to 1012 m square n. Okay, now what I am talking about, if you take the consecutive terms, okay, if you take 1, 2 or 2 and 3, okay, 3 and 4, sorry, not 2 and 3, 3 and 4, and similarly 2022 and 2023, so you can find out that both of them difference is equal to 1. All of them has a difference as equal to 1. Now why I am saying so? Because you know the formula a square minus b square is equal to a minus b into a plus b. Okay, I can write this like that. And if I can do so, I can take 1 square minus 2 square. I can write 1 square minus 2 square as 1 minus 2 into 1 plus 2 plus 3 square minus 4 square, and I am taking in this in bracket. Okay, and similar fashion I will go on up to 2021 whole square minus 2022 whole square. Now this will be a bracket over here, okay, not, and the pair for 2023 is basically absent, okay. So you can see that the pair for 2023 is absent. How I'm choosing pair? That pair has the ending term with a negative square, okay, negative of a square, okay. So you can look at the pair. So these are the pairs which has the ending term has a negative whole square. So from here, if you solve this, what you will get, that is 1 minus 2 into 1 plus 2, and similarly this will be 3 minus 4 into 3 plus 4, okay, and so on up to the terms, and the result is basically given as 1012 m square into n. Now you can see that from here you'll basically get it 1 minus 2 is basically minus 1 into 1 plus 2. Similarly the other term you will get as minus 1 into 3 plus 4, and so on up to minus 1 into 2021 plus 2022, and the remaining term is basically plus of 2023 whole square. So let it be remain over here. Now you can see from here that if you take minus 1 as common, and the result was summation was equal to 1012 m square n. Now if you see from here, if you take minus 1 as common, you will find that this is the summation of the first 2022, the 2022 natural numbers, okay. So if you look at the summation, so that is what is the important step you need to understand in this particular problem. So this is a fairly interesting problem, and this types of problems actually chances of getting repeated in your next paper or attempts, okay. So if you look at this is the sum of the first n natural numbers, and where n is basically 2022 plus 2023 whole square, and the summation is equal to 1012 m square n, okay. Now if you calculate, the result will be equal to minus 1 times of, so if you calculate this result, this is 2022 into 2023 whole divided by 2, okay, plus 2023 whole square, and the result is equal to 1012 m square n, okay. Now from here you can definitely simplify this as, so if you take 2023 as common, the result will be 2023 from here, and minus this result will be equal to 1011, okay, 1011, and the result is equal to 1012 into m square n, okay, into m square n. And from here you can see that this is basically, so if you calculate the result, and if you see this is the difference, the difference is basically equal to 2023 minus 1011 is equal to 2012, and so this will get cancelled out with this particular term, and the result will be left out as m square n is equal to 2023. Okay, now you can basically factorize this 2023. So you can see that 2023 will be divided by 7, and this can be factorized as 289, okay, into 7, okay. Now why did I do so 289 into 7? So you will find out that this is basically an exact square, okay. 289 is an exact square, all right, and 289 is exact square, and similarly 7 is another number. So you can find out that 289 is basically 17 square. So 17 square into 7. Now what you see that 17 square is basically the value of m, and 7 is the value of the n. So you can see that m and n are basically have a GCD of 1. So from here you get the value of m as, m as 17 and n as 7, okay. So from here you can definitely write answers for this particular problem of m and n, but the question is asking you for more than, the question is asking you for the value of m square minus n square. So m square minus n square, so if you find the m square is basically 289 minus n square is basically 7 square, that is 49. So from here you can definitely result as 240. So the answer to this particular problem will be option number C. So this was basically a bonus problem that I was talking about, okay. Now why did I talk this bonus problem? Because this is a problem which actually get repeated in JEE Advanced, and similar kind of problem was actually asked in JEE Mains. So from here another thought of the day, so like you can understand, like it's a tip or a guide from my end, is that you also need to prepare some easy or the immediate level problem of JEE Advanced previous year questions for your JEE Mains. So you can expect that JEE Advanced question also get actually repeated in your JEE Mains paper, okay. So with this, that was my take on the chapter of sequence series. I hope you have enjoyed solving the questions of sequence series as much as I did. All right, so okay, so we completed the entire portion of sequence series. So yeah, so today's goal is basically covered, and with this I come to the end of this particular lecture. So if you have enjoyed watching this particular lecture, don't forget to like and subscribe to my channel, okay, and keep watching for the upcoming contents. And on this particular I will be uploading the next concepts and the chapters on algebra, okay. I will be taking with matrices and determinants, and then I will moving on to the other important topics. So before your JEE Mains first attempt, you can guarantee that your mostly 70 to 80% of your syllabus will be covered from this particular sessions. I hope if you will follow this particular lectures and take most benefits of them. So with this, thank you.